Hi, my name is Brian Slagowski, and this video is about my solar energy harvesting project. The first part of the project had us model a solar cell using LT-Spice. So this would be the solar cell, and then this would be the resistance of the load that you would be applying to the solar cell. So then looking at the current voltage curve, behavior curve of the solar cell. This down here gives us the I short circuit, which is negative 40 milliamps, and then we have the open circuit voltage point up here. Then in this graph we added the power curve, and then so right here is the maximum point for the power curve, which is giving you the fill factor. And then down here we utilized the LTC3105 chip, and this here is just a basic design that you get when you pull up the 3105 chip. So this is just the basic model for it, and then doing the actual graph Vout for it. This is what it looks like. So then we had to utilize, if you notice right here, they just have a generic voltage input. So we have to utilize two of our solar cell models here in parallel, and that is then connected into the input. And so then we have the whole LTC3105 with the two solar cell models over here, and then we graph the output, and you can see here that we are getting a 5-volt output, and then this here is a negative 5 milliamps. That's big. The output is a 5 milliamps, and that just changes on whatever the load resistor is, so that changes, but the voltage there is a 5-volt voltage source. So in the next phase of the project, we had to actually prototype out our design on breadboard, and so this here is the design. We've got some resistors over here, capacitor. This here is the inductor, and then that is the LTC3105 chip in there, and they just have it on this chip here, so you can actually utilize it on a breadboard. And so testing that design out, down here we have, this is the is connected to the prototype board, and so this is the actual input that we're supplying. We're using a generic voltage input here, but this here is showing that we are getting an appropriate output utilizing that. So once we've actually prototyped it on a breadboard, the next step was to then use DipTrace here, and DipTrace allowed us to do the PCB design for our circuit here. And so here we have the 3105 chip. Here's a couple of resistors, capacitors, and another capacitor. Here is an inductor. This is a USB connector, so that way we are able to connect in any USB device that's able to take a 5-volt output, and that's what we're going to be able to charge with our device. And then this big pad down here is the space for where the actual solar cell is going to go. And also over here on the side we have the specifics about the actual resistors and capacitors. So our capacitor size was an 0805 and our resistor size is an 0402. And so that was just the PCB design, and then once we got the PCB design done, we actually had to then go through and do surface mount soldering of all of our pieces. And so this is the actual PCB design once we got it back with all the pieces actually soldered on. And then here we are actually having this wire that goes from the top of the solar cell, which is the ground side, and that's wiring into the ground here, and then the other side is connecting in to the VN source. So that's where the power is coming from. So once we had everything completely soldered together, we had to bring it over to the testing station where we had it under a lamp to provide enough illumination. And so here you can see we have it connected to ground, and then the voltage out, and the actual picture here we have 5 volts. This does actually do a ripple voltage like the simulator showed. This picture just, we happen to catch it right at 5 volts. And so that concludes my video about the solar energy harvester. Thank you for watching.